Now let us discuss mesh analysis. Now one thing about mesh analysis is that it can be performed only on planar circuits. So we will see what is this planar circuits. Whereas nodal analysis, it can be performed on both planar as well as non-planar circuits. Okay, so that is one point of difference between the nodal and mesh analysis. So what is a planar circuit? So if you can see here, let us take a circuit. Here is a resistance, here we have a resistance, and here we have another resistance. Now in between you have one resistance and here you have one resistance. Now you can see that this resistor here, this is crossing over this resistor. Okay, so if it is possible to draw this resistor in such a way that it is not crossing over any other circuit element, then it is a planar circuit. So here you can see that this is possible. So if you redraw the circuit like this, here this resistors we can draw as it is, and this resistor also we will draw as it is. Now you can see that this resistor, it is in between this point and this point. Okay, now what if you can just draw it like this? Okay, so now you can see that no resistor or no circuit element is crossing another circuit element. All of the elements can be represented in a two-dimensional plane, right? So this is an example of a planar circuit. This is example of planar circuit. The first form and the second form, even though both are same, in the first form you can see that this resistor, it is crossing this circuit element, this resistor. Okay, but if you redraw it, you can see that it is indeed a planar circuit. Now if you see one example of non-planar circuit. So non-planar circuit, it is going to be in a little more bigger circuits. Okay, and we will often not encounter it in this level of study, so don't have to worry. If you take a cube for an example, so I'm just drawing it without the circuit elements, but you can consider it like each of the lines here, they are representing some circuit element. It might be a voltage source, it might be a current source, or a resistor, capacitor, anything. Okay, now if you take a diagonal element, that means you connect a circuit element from one end of the diagonal to other. Okay, then what is going to happen? Can you draw this element in a two-dimensional format? Never. This element is always going to cross over another element whenever you try to draw it in a two-dimension plane, right? So this is one example of a non-planar circuit. Now mesh analysis cannot be applied to this, but you can apply nodal analysis. Okay, so this point is important. Nodal analysis can be applied to both planar as well as non-planar circuits, and that is not the case with the mesh analysis. So now we will see the step-by-step procedure. Okay, so what is the first step? You have to identify the meshes. Okay, so identify the number of meshes. And the next step, it is going to be, you have to assign mesh currents. Just like in the case of nodal analysis, you have identified nodes there and you have assigned voltage to each of the node. Here what you have to do, you have to assign currents to each of the meshes that you have identified. Okay, so what is a mesh? A mesh is nothing but, this might be a confusion, so mesh is nothing but a loop, any loop with no other loop within it. Okay, so this point is important. So now the second point is assign mesh currents. So once we do an example, it will be more clear to you. Okay, the mesh currents, they can be either taken in clockwise sense or counterclockwise sense. And the third step is write KVL equations. What is KVL? Kirchhoff's voltage law. So write KVL equations for each of the meshes in terms of the mesh currents. So we want the equations in terms of mesh currents. Then what is the final step? You have to solve the equations to find the mesh currents. Okay. So here we will take a simple example, okay, just for the sake of knowing how to apply the mesh analysis. Okay. So here you have 3 resistors in parallel. Take this to be some 7 ohms. This voltage is 60 volts, 12 ohms, 6 ohms and 12 ohms. Okay. So what was the first step? The first step was to identify the number of meshes. How many meshes do we have here? Okay. So this here is one mesh. Okay. And this is one mesh and this is another mesh. So you have 3 number of meshes here. Okay. Number of meshes is equal to 3. Now what is the second step? You have to assign the mesh currents. Okay. So what are the mesh currents here? We will take for each of the mesh, we will take as I1, I2, I3 in the clockwise direction. Okay. So this is I1. This is how you assign the mesh current. So mesh current is a little different from the current through each element. So we will see how that is the case. Okay. So we have assigned mesh currents in the clockwise sense. I1, I2, I3 in clockwise sense. Then next step 3 is the most important step, to apply KVL. Okay. So we will apply KVL one by one. In loop 1 or mesh 1, when you are going in the clockwise sense, for this voltage source you are encountering the negative polarity first. Okay. So you have to write minus 60, and the resistors you can take the polarity in the direction of the current. Okay. So for this resistance, the voltage drop is going to be 7 times I1. Okay. So plus 7 I1. And on the next resistor, there will be a slight difference here. For the 12 ohms, I1 current is flowing like this. Okay. But I2 current is flowing like this in the opposite direction to I1. Okay. So this resistor, because it is in between both the meshes, it is going to have both the mesh currents. Okay. So that is the important point that you need to understand when you are doing the mesh analysis. Okay. So here you are going to write plus the resistance value into the current. Since we are going in the clockwise direction, which is downward, you have to take whichever current is in the downward direction, that will be positive and the other will be negative. So I1 minus I2, this is equal to 0. Okay, so this is the first equation. Next, if you take loop 2, here you have only resistors. So now here also in the clockwise sense. Okay, so here you have, first we will take the 6 ohm. I2 is flowing in the direction that we are taking, I3 is in the opposite direction. So we are going to write 6 times I2 minus I3. Okay. Then 12 ohm resistor, I2 is in the same direction that we are taking. So plus I2, and I1 is in the opposite direction. So minus I1. So this is the second equation. And in a similar way, loop 3, what will be the equation? First, if you take the 12 ohms, here it is associated with only one mesh. So only I3 current. Okay, so 12 I3 plus 6 times, here I3 is in the prescribed direction. So I3 minus I2. This is equal to 0. This is the third equation. Now what is the final step? You just have to solve these 3 equations. Okay. So if you solve, you can solve it. I will give you the final answer. You're going to get I1 is equal to 6 amperes, I2 is equal to 4.5 amperes and I3 is equal to 1.5 amperes. Okay. So this is how you have to do the mesh analysis. Now one more important thing that I want to say here is, there's an easier method to write the KVL equations in which you will get in a direct form, some coefficient into I1 plus coefficient into I2. So if you want to get in that form, then you can write the direct equation. So how can you do that? In loop 1, if you can see, minus 60 will remain as it is. So let's just write the equation once again. Or minus 60. Previously we have taken per resistor. That means for 7 ohms, what is the voltage drop? For 12 ohms, what is the voltage drop? Now we are going to take in terms of the mesh current. Okay, so I1 drop is going to be across 7 ohm as well as 12 ohm. Okay, so 7 plus 12 is 19. So plus 19 I1. Now what about I2? I2 is also flowing through this, right? It's a common branch. So now the drop across 12 ohm because of I2 will be minus 12 I2 because it is going in the opposite direction. We are taking KVL in a clockwise direction. So it is in the downward direction, but I2 is flowing in the upward direction. So it is going to be minus 12 I2. This is equal to 0. Okay. So you can see that this equation and this equation is one and the same, but you are getting directly all of the I1 terms you are getting in the one go. Okay. From here again you will have to get this form. Instead you can write this form directly. Okay. So that is the point here. Now in this similar way you can apply for the second loop as well. So for the second loop I2 is going through 6 and 12. So 6 plus 12 is 18 I2. So 18 I2. Okay. Now I1 is flowing from in the opposite direction only across 12. So we will write minus 12 I1. Similarly minus 6 I3. This is equal to 0. So this is equation 1. This is equation 2. Similarly equation 3, what is it going to be? 6 plus 12 18 I3. Okay. Minus 6 I2. This is equal to 0. So this is the third equation. Okay. Now what if, just for the sake of better understanding, what if you take the current directions in the opposite direction? That means we will take the example differently. So let us say here you have a resistor, here you have a resistor. Okay. So now let us say this current is I1 and this current you are taking as I2. Okay. Then what will be the equation? So we will take here simply R1, R2 and R3, and this we will take as Vs. Okay. So this is another example. So now if you want to apply the KVL in loop 1. So what will you get here? Minus Vs plus R1 plus R2 I1. Okay. Now I2 you can see that it is also flowing in the downward direction, same direction as I1. So here you are going to get plus R2 I2. Okay. In the previous case when we took the current direction I2 in the clockwise sense, in the same direction as I1, that is this is also clockwise, this is also clockwise, if you take, then you got minus R2. But if this is clockwise and this is counterclockwise, then plus you are going to take. Okay, so this is equation 1. In the second mesh, you are going to get, in the loop 2, you are going to get R2 plus R3 I2 plus R2 I1 is equal to 0. Okay, so this is how you have to write the mesh equations. Once you know how to write the mesh equations, then finding out the solution, solving it is not going to be a very big thing. Okay. Now next comes the case wherein we have current sources in the meshes. Okay. And sometimes when there is a current source, we are going to get a super mesh. So we will see what is that case. Okay. So we will take an example here so that you can understand better. Here you have a resistor, here you have a resistor, and here you have a current source. Okay. And here you have a voltage source and a resistor. Here a resistor. Okay. So let us say this is 2 amperes. This is also 2 amperes. We'll take this as 2 volt, 1 ohm, 2 ohm, 1 ohm and 1 ohm. Okay. So now you can see here that how many meshes do we have here? You can go in the same procedure. Step 1, number of meshes. So this is going to be 3. This is one mesh, this is one mesh and this is one mesh. Okay. Now we will start assigning the mesh currents. Okay. So we will take all of the mesh currents in the clockwise direction. So here I1, this we will take as mesh 1, mesh 2 current is I2 and mesh 3 current we will take as I3. Okay. So now you have two kinds of cases. So what is that? In this case, in this current source, it is associated with only one mesh, that is the third mesh. in this mesh, there's going to be this current source is associated with two meshes, 1 and 2. Okay, so in both the cases, how it is going to be different. So step 3 is to write the KVL equations. So you can see that I3 mesh current is simply equal to 2 amperes. Okay, because in this mesh I3 is flowing. Okay, in this resistor what will be the current? I3 minus I2. In this direction if you take I3 minus I2, and for the 1 ohm the current is flowing I3 in this direction, I1 in this direction. So if you take in this direction, I3 minus I1 you can take when you are applying for the mesh 3, if you are applying KVL. Okay, but the current through this is nothing but I3 and the current through this is nothing but 2 ampere. So I3 is simply equal to 2 amperes, right? So there is no confusion here. It has made things simpler. Okay, but here you are going to be slightly different. You can see that since current is flowing in the upward direction, 2 ampere, this I2 is flowing in the upward direction, I1 is flowing in the downward direction. So what will be the equation here? This is going to be I2 minus I1 is equal to 2 amperes. So this is equation 1, this is equation 2. Then how will you write the third equation? This is where the concept of super mesh comes into picture. So what is this super mesh? Just like in the case of super node, wherein we have taken 2 or more nodes together and applied the KCL by considering all of those nodes as a super node. Here also we are going to apply KVL, Kirchhoff's voltage law, by considering more than one mesh. Okay, so what is that more than one mesh? So this is going to be the super mesh. Okay, so that both the meshes with which this current source is associated, those meshes are included in it. Okay, now you're going to apply KVL for this entire super mesh. Okay, so we will see how that goes. Applying KVL to the super mesh. Here you're going to get, so each of the elements you can take. First we will start with the voltage source. So if you're going in the clockwise direction, then minus 2 will come first. So minus 2. Now you can go in the conventional method wherein you can write voltage drop across each of the resistor. That means if you write 2 ohms, then 2 times I1 plus here drop across this is 1 times I1 minus I3. You can write like that, or we can write directly like I just told. Okay, so what is that? I1 is flowing in this direction, is associated with 2 ohms and this 1 ohm. So we will write plus 3 I1. Okay, now for these two resistors, the current that is associated is I2. Okay, so 1 plus 1 into I2. So you get plus 2 I2. Okay, but through this 1 ohm, I3 is also flowing. Through this 1 ohm also I3 is flowing. So we will have to incorporate that also. We are going in this direction. I3 is flowing in opposite direction. So minus I3. Okay. Similarly, here 1 ohm also I3 is flowing in the opposite direction to what we are taking. So it is going to be another I3. So I will write here minus 2 I3. Okay. So this is going to be 0. Okay. So here you have another equation. So now we have 3 equations in 3 variables, one of which we already found out. Okay. So this is how you're going to get the equations for a super mesh. When there is a super mesh, one equation is by applying KVL to that super mesh, and the other equation is by writing the equation for that particular current source. This I2 minus I1 is equal to 2. Okay. So this is how, when a super mesh comes in, you have to do the mesh analysis. So now the final question is when to apply mesh analysis, when to apply nodal analysis. So the first thing that we have seen anyways, for a planar circuit, both can be applied, but for a non-planar circuit, only nodal analysis is going to work. Okay. Now the second difference comes wherein there's more number of parallel connected elements or more number of series connected elements. Okay. So if there are more series connected elements, okay, so that means more elements are in series, then it is better to do the mesh analysis. Okay, and if there are more parallel connected elements, then it is easier to apply the nodal analysis. Okay. So these are just general observations, but when you practice more, you will automatically find out which one is more convenient, whether mesh analysis is more convenient or nodal analysis.